A standard six-sided die is rolled. What is the probability that the roll is a prime number or an even number? Okay, so we have two events here, a prime number, and an even number. Well, so we're looking here for the probability that it's prime or even, so E or F, okay, E union F. Our formula for this is the probability of E plus the probability of F minus the probability of E and F. In other words, the probability of E intersect F. So we go through and do each of these. The probability that you roll a prime number, we need to think about how many prime numbers there are on a six-sided die. So the prime numbers from 1 to 6 are 2, 3, and 5. So there are 3 numbers, 2, 3, and 5, out of the 6 on the die. Plus the probability of rolling an even number. Well, on a six-sided die, the even numbers are 2, 4, and 6. So again, there are 3 out of the 6 on the die. Then we need to subtract the probability that the number we roll is both a prime number and an even number. Well, the only number that's both prime and even is 2. So there's only one way that can happen. There's one number that satisfies both out of the 6 on the die. And then we can simplify this. That's 3 plus 3 minus 1, which is 5 out of 6. Now, for B, what is the probability that the roll is less than 3 or divisible by 3? Now, if we look at this, there is no number that is both less than 3 and divisible by 3. So these are mutually exclusive events. Okay, so E is less than 3, F is the event divisible by 3. Divisible by 3. Okay, there is no way that a number has both of those properties. Therefore, these are mutually exclusive events, so the probability of E or F is simply the sum of the two probabilities. The probability that you get a number less than 3, well, that's just 1 or 2. So there are 2 ways that can happen out of the 6 on the die. Plus the probability that it's divisible by 3, well, the only numbers divisible by 3 on a six-sided die are 3 and 6. So there are 2 of that kind out of the 6. And we add these together, we get 4/6, which reduces to 2/3.